Hello viewers, good afternoon once again. You are welcome to our online teaching series. Today we are going to briefly take a look at practice question number 7, a problem in physics. Now on that way we have a challenging problem that is simple to tackle. Now the plane progressive wave is represented by the equation y equal to 5 sine bracket 2000 t minus 40x. They said we should calculate wavelength of the wave, 2 frequency of the wave, and 3 speed of the wave. How do we solve this problem? I would like you to follow me as we solve this problem. Now in solving this problem, the first thing we have to do is to take on the line, take a look at the equation given to us. Now the equation given to us states that y is equal to 5 sine bracket 2000 t minus 40x. Now the next thing is to compare this equation to one of the general equations of the plane progressive wave. We have several of them. Now you look for one of them that can complement this particular equation given to you from the question. Now we have one of such as y is equal to a sine bracket wt minus kx. Now take a look at the similarity between these two equations. Here we have 40x kx, we have 2000 t, we have wt. Here you have 5, you have a, you have sine. But you can see how everything can be compared. Now in comparison, we should understand that from here that 2000 t should be equal to wt, and also 40x should also be equal to kx. Let us solve for question number 1. Question number 1 says we should calculate the wavelength of the wave. Wavelength of the wave, which is lambda. Now, how do we solve for the wavelength of the wave? Take a look at this. You compare these two equations. Here is equation 1, and we'll have this as equation 2. In equation 2, I have that 40x is equal to kx. What is this k? K is equal to wave number, the wave number, and it is equal to 2 pi all over lambda. So if I substitute 2 pi over lambda for k here, I will have 40x is equal to 2 pi all over lambda. Remember, I have x here. If you cross multiplying, I have 40x lambda will be equal to 2 pi x. This is what I'm looking for, lambda. So our lambda will be equal to 2 pi x all over 40x. Obviously, x will cancel out. So we are left with 2 pi all over 40. And we know pi has a value. So our wavelength, lambda, will be equal to 2 times 3.142 for pi divided by 40, and this obviously will give us 2 times 3.142 divided by 40, and that is giving us 0.157 meters. So therefore the wavelength of the wave is equal to 0.157 meters. And number two, we have to solve for the frequency of the wave. The frequency of the wave f. How do we solve for the frequency? Again, we go to equation 1. In equation 1, from what we have up there, equation 1, we have that 2000 t is equal to omega t, where our omega w is equal to 2 pi f, the angular frequency. So if I substitute 2 pi f for w here, we have 2000 t will be equal to 2 pi f t. This is our area of emphasis, the frequency. So the frequency will be equal to 2000 t divided by 2 pi t. Here also t cancel out. So we are left with 2000 over 2 pi, and that is equal to 1000 pi. And we know that pi have a value of 3.142. So the frequency will be equal to 1000 times 3.142, and that is equal to 3,142 hertz. Remember, the unit of frequency is hertz. That is the frequency. And finally, number 3, the speed of the wave. Speed of wave, number 3. Remember also speed of wave. Speed of wave, which is V, is equal to F lambda, where F is the frequency and lambda is our wavelength. So the speed of the wave will be equal to the frequency is given to us as 3142 multiplied by the wavelength. We have the wavelength as 0.157. So 0.157 multiplied by that here, multiplied by 3142. That is giving us 3142. That is giving us 3142, right? That is giving us the speed of the wave is equal to 493.3 meters per second. So therefore, the speed of the wave is equal to 493.3 meters per second. Remember, the unit of speed of a wave is meters per second. With this, I believe this short solution reached you there at a very nice peace of mind. Please sit down tight, marry what you have seen with your textbook, and explore more. And I believe at the end of the day, every bit of thing that has to do with wave will be a thing of the past. Thank you until we meet in our next series. Bye for now.